So let's look at one more example. So this one. Which of the following is incorrect? And we've got A, B, C, D to choose from. So let's start. Let's write out A and evaluate this expression. So A is equal to cosine 2 pi is equal to secant of 2 pi. And again, we're just evaluating these to see if they are equal or not. So looking at this, let's write down the identities that we can use. So we know that secant theta is equal to 1 over cosine theta. So simply just rewriting this, I can say this is cosine 2 pi is equal to 1 over cosine of 2, 1 over cosine of 2 pi. So cosine 2 pi, again, just knowing that cosine goes like this. 2 pi is out here. It crosses at half pi. Just knowing that 2 pi is my cosine is equal to 1. So cosine 2 pi is equal to 1. 1 over cosine 2 pi is equal to 1. So 1 is equal to 1. So we know that one is correct. So let's move on to let's look at B. I'll rewrite what B is, and it's 2 times cosecant pi over 2 is equal to 2 times cosine squared 2 pi. So let's evaluate this, the left-hand side of the equation here first. And first, let's write the identities that we know. Cosecant is equal to 1 over sine. So if we plug into this, we've got 2 times 1 over sine of pi over 2. And what is sine of pi over 2? Just knowing that the graph of sine looks like this. Knowing that this is one complete revolution at 2 pi. This is pi, and this would be half pi. So sine at half pi is equal to 1. So we got 2 times 1 over 1 is equal to 2. So let's look at this side over here. And I'm going to show you an easy way first, and then I want to show you the hard way second. But hey, easy stuff first, right? So anyway, 2 times cosine of 2 pi squared. So what is the cosine of 2 pi? And again, we'll draw our graph out here. So this is cosine. This was sine. Don't get them confused. So we want to look at cosine of 2 pi. We know that 2 pi is out here. So what is the cosine at 2 pi? Well, I know it's 1. So this is the same as saying 2 times the cosine of 2 pi, which is 1, and it's squared. So 2 times 1 squared is 1, which is equal to 2. So 2 is equal to 2. But let's look at, we've got all these fancy identities in our reference handbook, and let's try to evaluate this actually using one of those identities. So let's look at the double angle formula, and let's start with, I need to give myself just a little bit more room over here. So let's look at, again, this using the double angle formula, and I'm just going to write this out. So we've got cosine, and I'll do this in a different color so we just don't confuse it quite so much. So cosine 2 alpha is equal to cosine squared, and again, this is straight out of our handbook. Cosine 2, or cosine squared alpha minus sine squared alpha is equal to 1 minus 2 sine squared alpha is equal to 2 cosine squared alpha minus 1. Kind of messy. But anyway, to evaluate this using this identity, well, let's look at this component and this component because it kind of looks similar to what we're trying to do, right? So again, just rewriting this is equal to this. I don't need all this other trash in the middle. So we got cosine 2 alpha is equal to 2, and this is just rewriting cosine or 2 cosine squared alpha minus 1. Well, let's see if we can rewrite this function over here. So I could move the 1 over, and I could get cosine 2 alpha plus 1 is equal to 2 cosine squared alpha. Well, hey, check it out. This looks just like this, right? So if I just want to rewrite that, then just moving this over here, I've got 2 cosine squared 2 pi, because it just, again, it's just plugging, this is alpha, plugging that into that equation. I'm just moving it over to this side, and then moving this component over to the other side here, and plugging in alpha. So cosine 2 times alpha, which is 2 pi, plus 1. Well, what do I know about, and now I'm just going to solve for this. What do I know about cosine of 2 pi? Remember how I did over here? Here's my cosine graph. 2 pi was equal to 1. So this is equal to, oh, wait a minute. It's 2 times 2 pi. So this is actually cosine of 4 pi plus 1. Well, what do I know about 4 pi? Well, I know that cosine keeps repeating on and on and on in the same fashion. So 1 complete revolution is 2 pi. So if I keep going, that's 2 complete revolutions. So, and I hope you can see that 2 pi is going to be the same or 4 pi is going to be the same value that we would get at 2 pi, because it would just keep repeating, and it's all bounded by 1. So cosine of 4 pi, and I'll just write this, since cosine repeats every 2 pi, so we know that cosine of 4 pi is equal to the cosine of 2 pi, and we know the cosine of 2 pi is equal to 1. So this whole function, the cosine of 4 pi is equal to 1 plus 1 is equal to 2. So hey, look at that. Remember when we evaluated this side over here is equal to 2, so 2 is equal to 2. But again, much easier to just either use your calculator or simplify, for me, using graphs. So let's look at, I think we're on C now. So let's rewrite C. So C is sine of 3/2 pi, which is equal to cosine 3 pi. So the best way to do this, I think, is to graph it out. So let's do the graph of sine first. So we know that this is a graph of sine. This is 1. This is -1. 1 complete revolution is 2 pi, and I'm going in 90-degree or half pi increments. So this would be 3 pi, this would be pi, half pi, and of course it's 0. So sine of 3/2 pi is just coming down, which is equal to a -1. Now let's look at cosine of 3 pi. So let's graph cosine. So this being cosine, +1, -1, 0. It crosses the x-axis at half pi. And again, going in 90-degree or half pi increments. Crosses again at 3/2 pi, 2 pi. And this is just carrying it because it continues to repeat, so just carrying it on out. 2 pi plus another half pi increment is 5/2 pi plus another half pi increment would give us 3 pi. So what is the cosine at 3 pi? It's equal to a -1. So we know that these are equal. And just one thing to point out on the cosine of 3 pi, you don't have to draw this out where it continues to go on. Say you had 10 pi or something. 3 pi is the same as 1 pi, which is the same as 5 pi, and so on and so forth. This is always going to be equal to a -1. So let's move on to our next expression to evaluate is d. And d is the tangent of pi over 4 is equal to sine of pi over 2 divided by the tangent of pi. So let's look at this one. And I think probably the easiest way to evaluate this one, instead of graphing it out, let's just plug into our calculator. So again, we need to change our calculator, put it in radians. So I hit shift mode and I hit 4 to put it in radians, and I want to do the tangent of 1/4 pi. So I hit tangent button, then I do the numerator denominator button, and I can put shift and then pi and all that divided by 4, which is equal to 1. And now I want to look at the sine of half pi. I'm still in radians. So I go hit the sine button, and then I do pi divided by 2, which is equal to 1, over tangent of pi. Hit the tangent button and shift for the pi, and I get 0. So 1 is not equal to 1 over 0. That would be undefined. So there we have it. And just to carry on, just to some additional information on pi. Let's look at what the graph of pi looks like, because we've graphed all of our other functions. And so it's slightly different. And let me draw put my half pi here. Pi, 3/2 pi. This is a -half pi. And I'm going to do something slightly different. I'm going to draw some asymptotes here. So what does tangent look like? Grab a different color. This is a graph of tangent. It starts at -pi or -half pi, crosses the axis at 0, approaches half pi, never quite gets there, keeps going forever and ever, then repeats in the same manner. So starting at +half pi, crosses at pi, approaches 3/2 pi, and never quite get there. So I think in this example, we were asked to evaluate pi over 4, or tangent of pi over 4 and the tangent of pi. So let's look at that. What is the tangent of pi over 4? Well, where's quarter pi? If this is half pi, then quarter pi is right here. That being positive 1. So tangent of, oops, that is quarter pi. Tangent of quarter pi is equal to 1. We're also asked to evaluate tangent of pi. So what is that equal to? Well, if I look at pi, tangent crosses the x-axis there, so tangent of pi is equal to 0. There you have it.